Okay, so last time I was a bit sick, that's what I was referring. So I had something to blame of the so I was sick and it didn't come out good. Now I'm the only person to blame. So, without any further ado, 10 minutes about C++ core guidelines. Now a bit of an introduction how I chose the core guidelines which I'll talk about this time. I needed to do a small project about talking with Kramer driver. And oh, by the way, if anyone knows how to install a COM driver without installing the whole software around it, I'd like to hear about it, because I didn't manage to find one already yet. And while I was trying to work with it, I thought to myself, this is Resource Manager. I heard in this in a previous session about RAI. Let's read about it. But before I started reading about the RAI, I got to this. That doesn't work. Next, this.
שם זה קופץ.
Refer ensures for expression post-condition. Actually, I encountered this after I read about RAI, but I think that it's a nice introduction. What happened? What you actually we usually do in a code, some of us do. You put an assert after a condition. You say, this has to be null, this has to be closed, whatever. But you never know if this is a precondition, a post-condition, what kind of condition is. So according to the guideline, we should do ensures. Ensures should mean that it's a post-condition. After this stage is ensured to have this rule or whatever. But it pretty much works like a normal assert, and it's pretty much useless because you need to remember how to put it every time inside your code. So, from what I read about it, it's basically like an introduction to contract design, which you will inside your code write what's expected, what it ensures, or not if kind of assert. But it's not yet fully formulated. I don't know if it's even there's a draft which I skimmed through it, and it's very long, so I don't know the exact details. But it seems as if it's not even on the table for discussion right now in the CPP meeting. So it's nice to know that it exists. Use it if you want, but that won't really give you much food forever. RAI. This is what I was really looking for. You want a simple way how to open a resource and close a resource. So these, I think Strustrup said it's the worst acronym in C++ history. Basically, resource acquisition is initialization. To put it in one line, do all the resources initialization in your constructor, put all the closing uninitialization, whatever, in your destructor. That way, once you create an object, you have the resource. Once your object goes out of scope, the resource is fully closed. So instead of doing creating a port instance, doing an init, and then writing something, and then closing, and we always forget to close, you just create the instance, you do whatever you want, and you know once it's out of scope, the resource is released. Sometimes it's a bit complicated to do it, because like in my instance, what I found out that I needed to create an object, in order to open the object, I needed to first list the devices which are connected to the system. Now, why they had such a design, I do not know. So, but that was how it was. So I needed to actually create a static function which lists it, and then I used to call first the static, then only create it. But usually there's a quick workaround, something like that. Next one. All resources acquired by a class must be released by the class destructor. Basically, it's like a subset of the RAI. Once you do RAI, you actually are doing this rule. So, but usually in the first lesson in C++, or the second lesson, they tell us in the destructor, release on the memory. Here they're talking about every resource which you obtained, close it, finalize it, whatever, in the destructor. And that way you conform to RAI.
I have a very last question.
Yes,
how
Isn't it against the Maya's suggestions about acquiring missiles? So he suggests to extract it from the constructor because constructor doesn't require any effort for it. It's one of its suggestions.
For exception. So the creation of your resource should be wrapped with by a try catch.
So if I don't want to use exceptions, if it's common for my code, it's not.
Then you use a factory. Factory, that's the factory. Factory is the static function.
That wasn't a factor. That was simply I needed for some reason to list all the devices connected, and only then I could connect to them.
Okay.
For some reason which I do not know. It's not my code. Alright. Okay, so this is it. Next one, C4GC. A base class destructor should be either public and virtual or protected and non-virtual. The reasoning behind it is very simple. You've got a pointer to the base class. You create a derived class. You destruct the base class. And if it's not virtual, then your derived destructor isn't called and the resource isn't released. But when I was reading it, I was like, wow, this is important. If you're using RIAI, this is really important. And that's why I put it. It's a small meaning. Avoid singletons. Please avoid singletons. I remember my previous job, we had like about 10 singletons, and each singleton needed a different singleton, and you had to just, at the beginning of your class, you need to just call the singleton just to make sure that they were created properly. Avoid singleton. But you can't always avoid singletons. And sometimes you need to do weird things like a weak singleton. Because you wanted, if no one is referencing the singleton, you wanted to be destructive, just not to take enough resources. I actually planted it's a pretty cool thing. Maybe, I don't know. But if you're using a singleton, then actually nowadays, don't use your own double check clock. Use either a call once, which is new in C++11, or use a static class, my class, my object. Now, there used to be a problem with static classes, the way they are initialized. Now it's a bit better in C++11. You still could go into this is just to take time because I didn't have enough slides for 10 minutes. So this was so I'm moving it to the left hand, I'm less likely to press things less active. So the static, there's the usual problem when you create a static variable and call it in two CPP files, two compilation units, and which one will be created first. It's pretty much random. But now in C++11 it's a bit better because simple construction are constructed on loading of the program. So by the runtime state, everything should be loaded. So this is a bit safe. What?
Not static.
C++11 in trivial constructors, they are constructed and initialized under loading of the program.
In short, they are initialized for safety, which Visual Studio only implemented correctly from 2015.
From what I know,
it's called magic statics.
So from what I know that if your constructor is a const expression, then it should load. It should load the entire. I'm fairly sure because before I wrote the slide, I read about it.
Two different types of statics. You might be right about the global scope, and I was referring more to local statics inside functions, which are a great way of initializing safe and single points.
But that has a terrible way. You hit a memory barrier every time you go through that function.
No.
Because you have to check whether you've initialized them every single time.
You're adding a lot of overhead. It's very easy to write, but it has performance penalties.
Why?
Usage.
You could lose as much. If it's out of cache, you can lose a lot of time. Like dozens of nanoseconds.
Okay. But if you do need to use static, you do need to implement, then use a double checking locking. Use a double checking locking. Small anecdote. In nearly every time I got interviewed for a job in C++, I was asked to implement a double checking locking. It became so boring that the last interview stopped asking this question. Everyone they were asking. So this is the normal. I think everyone got interviewed. I think in Israel in the past 5 years was asked this question. So if you need to do an action, you lock it, then you check again. If you need to do action, then you initially take the action. You change the flag. That's it. 10 minutes.
Thank you very much.